Hello, my name's Rich Murphy and I'm a VMAX PowerMax Principal Corporate Systems Engineer with Dell EMC. Today I'm going to take you through the latest developments with our non-disruptive migration feature for migrating from VMAX Hybrids or VMAX All-Flash running 5977 code to VMAX All-Flash or PowerMax running 5978 code. We are referring to this feature as Metro-based NDM as distinct from the previous pass-through NDM, which was for migrating from older versions of VMAX platform running 5876 code. With Metro-based, there are a number of improvements, namely the ability to pre-copy data to the target array before making the target visible to the host. This is unique to Metro-based NDM, and I'll take you through that in this demo. But first, for today's demo, I'll take you through a non-pre-copy migration to highlight some of the differences as we progress. So this slide just highlights the various different stages that the session can be in. Green being the happy path, so no issues all the way along from your create right through to your commit in progress and your successful commit in progress to your post migration. The blue bubbles just highlight the various different stages you can be in should you experience a failure at any of those steps, and again just the recovery scenarios. Just highlighting the happy path in this case, and bringing in some of the test environment that we're going to use. You see that our source will be 085 and our target will be 131, 085 running 5977 and our target running 5978. This will be our source and our target combination for the entirety of this video. That are going to be involved from the arrays I have in my lab here. So 085 being again our source, and 131 running 5978 code, 131. I have an animation at this point that highlights the various different steps of the migration and the plan for the demo. Down along the bottom here you see a progress bar and what step we're at in the process. My host is a Windows Server 2016 VM, and my source contains a storage group kt_metro_ia, and that contains volumes 4easy1 to 4easy5, and this will be the source, or this will be our storage group that we intend to migrate. Moving on to step, we want to first of all do our environment create, and that would be a one-time operation before we start any migrations between this particular source and this particular target. We set up that environment. That environment will create a template, which will be the I guess the template that all the further migrations are based off of, the various different groups. All it does really is effectively look at the RFs available and sets up that template. Once we issue create, the create command will look at this template and base this SRDF group it creates off this template. So it's a one-time operation that we set up before we migrate, and again once we are confident that all the migrations are finished between this particular source and this particular target, we can then remove that environment. So moving on, we issue the NDM create through either Unisphere or Solutions Enabler. What this command does is set up a storage group on the target array that mimics the storage group from the source array, and gives it the same name and creates volumes that are identical in size and number to the volumes of the source. We can't guarantee that the volumes will have the same volume ID, but they will be of the same size and number. And at this point we start actually synchronizing data, and that happens immediately once the stored group have set up and the various different SCSI information has been copied. We start that data synchronization. If those of you that may be familiar with the pass-through NDM, the previous version, this wasn't the case. We had to issue a cutover before any of this happened. But since this is Metro based, it allows us to just dive straight into that and cut out the cutover step entirely. So once that data is starting to synchronize, you can do a rescan of the host, and then we move into an active type situation. And from there we'll become synchronized once data has copied across, and we'll go in and just issue that NDM commit. Again, the 2 C's or the 3 C's have been reduced to 2 C's, so it's just create and commit as opposed to create, cutover and commit from the previous version. And again, as best practice, just issue that host rescan. This will all become more clear as we progress through the demo. So this is our all systems view. It just lists out the various different arrays I have in my environment. 085 at the bottom being our source and 131 at the very top of this list being our target. This is Unisphere 9.0. So we navigate to 085 source, and from the resulting menu we select data protection and migrations. And migrations will list any ongoing migration sessions on this from this particular array, and environments, any environments that are set up using this particular array. Since we don't have any at the moment, we select create, and from the drop down menu 131 being our target, and we click run now. So since this is Metro based NDM, every individual storage group that's been migrated requires an individual SRDF group, and what this environment create is doing, it's going out, it's creating that template that all these groups will be based on. And we can see the resulting environment has been set up, remote array being 131. Its state is currently green and it's not currently used, suggesting that no templates or no groups have been set up yet using this template. Navigating back to dashboard and to replication, we can see we've added a graphical view into the various different migrations that we environments that we set up, and you can see it's green here, which means it's a normal status. And heading back over to data protection and SRDF groups, you can see the resulting environment is a group 250 Fox 9 M underscore, highlighting that it's a migration environment, and you can see it's an online status. So now we're ready to start the migration of our storage group. So we navigate to storage and storage groups. From here we've listed potential storage groups to migrate. You can see KT underscore metro underscore IA as we intend, and just the volumes that you can click on, just take a look at those volumes, and we see 4EZ1 through 4EZ5, and I've just added some allocations there. So back to storage group view, we can also see that it's currently in a masking view to a host. So on with the migration, so you click the advanced menu and to migrate. From this menu you see the intended target 131 is the only environment that we've set up. We're going to choose SRP1 and we're going to select the port group, and this is an option that we've added at 9.0. So 9 potential port groups that are on the target array can be selected at this point. We click next, and in this case we're going to leave pre-copy unchecked, and you can see just the masking view set up and the various different summary of the intended migration, and you click run now. And on the left hand side, what I've done here is I've added the various different steps that this process is going through, and at the bottom you can see the exact same process using solutions enabler can be done with this command. So the operation has now completed, so we can click the close button, and that we don't take a look at what that migration looks like from the list view. So we go to data protection and migrations, and you can see here that the session is now active and it's in a migrating state. So the next step in the process is to rescan the host. We rescan the host so that we can pick up those extra paths to the target devices. If you're familiar with NDM and how it works, you'll know that NDM effectively uses device spoofing to trick, I guess, the host into thinking it has extra paths to the same source devices, whereas in fact it has spoofed paths to both now the source and target devices. This is how we're able to achieve a non-disruptive migration. So let's take a look at the SRDF group, and the resulting create command has created group 249. It's a dynamic group and it's in active mode, and just from the target you can also see the same resulting group has been created, and storage group again on the target array KT underscore metro underscore IA to replicate the source. So looking at this from our PowerPad standpoint, our multi-padding standpoint, and we're issuing the PowerMT display device command, which is going to choose the first device in our storage group, so 4EZ1. You can see that 4EZ1 now also is associated with logical device 23dog, which is the new device that we've created on our target array, and it's also associated with our target array 131. Down at the very end you see that the extra paths that have come in, and the resulting director and port numbers. Let's take a look at one of the devices associated with this migration. We'll go back to the source array, migrate to K3 Metro, and just volumes, and take a look at 4EZ1 like I showed you earlier. So we have an internal and external WWN. Now this is key to understanding how the spoofing is achieved. The WWN is the WWN the device was born with. The external WWN is the WWN the host can see. In this case, the source post-migration create hasn't been affected or altered in any way. So in contrast, let's take a look what is done to the target devices. So we navigate to 131 and take a look at the target storage group. And the first device being 23dog like we saw earlier. And what has that done to the WWNs? Well, what we see is that the external WWN has inherited the WWN of the target of the source device. This is how we achieve that spoofing through multi-padding software. So we go back to the source array. Again, this can be done from either source or target. Go to data protection and migrations list, and you can see here the migration again is synchronized. So we double click, and you can see the various different devices that are involved, the source and target devices, and their current status. By clicking masking view tab, we can get a deeper view into the various different elements of the migration session, the port groups, and the ports involved, and the initiator groups and those particular initiators that are involved, and their current status. So let's move forward to migration. So we want to navigate back to the migrations list, and from here we select our storage group and we click commit. You may see that there's also a cutover option. That cutover is solely for the pass-through NDM. With metro-based NDM, in this case, we just have that create and commit, so two commands, as opposed to the create, cutover, and commit that we require for pass-through modes. Once the commit is issued, it really is the point of no return. Anything up to the commit command is issued, you can non-disruptively cancel the migration. Everything will be as it was before the create was issued. Once the commit is issued, there is no way to non-disruptively migrate back or cancel the migration. So once you're satisfied everything is okay, you can go ahead and click that commit button and run now. And again, as I say, everything on the left hand side here is the discrete steps going on once we issue the command. So the RDF attributes removed, masking views removed, etc. And down the end you can see the solutions enabler command. So let's take a look at the storage group post migration. You can see that the migration session has been removed from the migrations list view. The storage group itself remains on the source but is no longer host presentable. That masking view has been removed. And looking at the target, you can see that storage group still has its masking view, so there's the only side of the storage groups that is visible to the host at this point. Back to the source, taking a look at the SRDF group that was created for the masking for the migration. You can see that it has been deleted, but the template remains to be used for any future migrations. So let's see what that commit has done to the source side storage group devices. You remember the storage group on the source side hadn't been altered in any way, or the WWN of the volumes hadn't been altered in any way post create. If we navigate to 4EZ1 now, we see that we've effectively done a full swap of WWNs. You see that the external WWN here has inherited the WWN of the target device. This allows us to maintain this hardware without any fear of affecting the host or the target application. Just to show the WWN of the target device, navigating to the target on the volume 23dog, we can see the WWNs as they were post create. They have still retained that external WWN of the source. So it's always good practice to rescan your host post commit, just to clean up any dead paths that might remain within your multi-padding software. taking a look at our PowerPath display, and we'll see what it looks like post commit and rescan. We'll see now that the logical device solely associated with these paths is 23dog and 131, and the only paths that remain that are alive are the two paths of the target array. That concludes the migration using the non-pre-copy option. What I'm going to do now is I'm going to go through the same operation using the pre-copy flag, just highlighting the differences. I won't go into as much detail in terms of the migration masking views, etc., WWNs, but you can assume that the same applies to pre-copy option. So once again, here's the process flow, this time with pre-copy. The happy path in green and the recovery scenarios in blue. What you may notice is there's a third user input called ready target. So the process flow being create with pre-copy, ready target and commit. What the ready target does is it brings the masking view live to the host from the target array. Up until this point we'll have been pre-copying data from the source to the target. Issuing the ready target moves us into an active-active scenario similar to what we had without the pre-copy flag. What we're noticing is most customers are waiting for the synchronize to be 100% finished before issuing the ready target and bringing those paths live to the host. So once again, we'll just do a quick animation of the demo and the plan for it. So our source being 085 again, and our target being 131. I've already set up a storage group called kt_pre_copy containing devices 4EZ6 to 4EZA, and the NDN template is already in place from the previous demo, so there's no need to do an environment setup command again. We'll then issue the NDN with the pre-copy flag, which sets up the storage group on the target array as before and the volumes. It also starts immediately copying SRDF traffic from the source to the target using adaptive copy mode, but it doesn't make the target visible to the host at this point. The tracks will continue to synchronize in adaptive copy mode until the user decides to issue the ready target and run that host rescan to bring that mode to active-active and to make the target devices visible to the host. At any point, this can occur in the process, as I said earlier, and we'll move from a pre-copy state to a migrating state to a synchronized state once the tracks have fully copied. Again, the user issues that commit command, which does something very similar to the previous demo. So let's start the demo. So before we'll go to storage group, storage groups. We'll highlight our intended storage group to migrate. We'll go to advanced, migrate, and again we'll choose our target, SRP1, our port group, and our target, and again click next. And from here the difference is we highlight the pre-copy option and click next, and again we get this summary of the intended migration that's going to occur. And run now. On the left hand side we see again the steps that go on with the pre-copy command, and below we see solutions enabler command with the pre-copy flag. So taking a close look at that migration session, we go to data protection as before and migrations, and taking a look at that list view we see that we have a new status this time, and it's a pre-copy state, and over on the right hand side you can see how much of that we have already completed. This will vary depending on your RS, etc., and the amount of data obviously you're transferring. Looking at the SRDF group, we see that we've created an SRDF group and we're in adaptive copy mode as opposed to active-active. Migrations, you click on the migration session and we see now we're 100% done. Again, the ready target can be issued at any point in this pre-copy phase. We'll do a rescan. and we'll do our ready target. So we'll click on our session, we'll go to advanced, and we'll click ready target. And again, over on the left hand side you can see exactly what's going on here in the discrete steps and solutions enabler command to the bottom. Once the ready target has been issued, a quick refresh of Unisphere will bring up the new status, and we see we've jumped into a migrating state. This is always a step we jump into regardless of how much we have already copied. It's just a temporary step. Another refresh should move us into a synchronized state. It's very important that you realize that we will never move into a synchronized state. We will always remain in a migrating state until both the data has finished copying and we've done that rescan. That SRDF group will now have moved from a adaptive copy mode to an active mode, and we can see that here. We'll just back to migrations and we'll do that commit. So effectively we've moved from the pre-copy code path back into our normal Metro-based code path at this point. The commit is exactly identical to the non-pre-copy mode on the left hand side and also in the command to the bottom. And that concludes our pre-copy demo. Just to summarize, the only real differences is the fact that now we moved from a 2-command operation to a 3-command operation. So from a create and a commit to a create, a ready target and a commit. The ready target making the masking view to the source array live to the host, all the while we are pre-copying data using an SRDF adaptive copy mode from the source to the target until we issue that ready target, whereby we bring those paths live and we move to an active mode. So what we hear a lot of in the field is how to identify LUNs that have been migrated, how to identify what LUNs my arrays actually reside on now that we use LUN spoofing. I have some tips and tricks put together here and how it might be useful to keep track of your volumes using labeling, etc., and how to use the INQ to identify LUNs and what array they actually reside on. So let's first of all start out with just showing you how we might use the INQ utility to identify devices post-migration. And we can see that we don't have any migrations live at the moment. They have previously finished from the last demo. So we just go to our storage group and we'll use that kt_precopy_storage group. And we see it doesn't have a masking view, and just a reminder of the devices involved: 4EZ6 through 4EZA on the source. And onto the target, we see obviously from the last example it does have a masking view, successfully migrated, and the volumes involved 24 Charlie to 250. So jumping into our INQ utility, issuing the INQ command, which is downloadable from the address on screen, you see that the serial number identified, and using the INQ minus native command, you can see how this contrasts 249 to 248 using the native. So as you can see, it's showing the device serial number of the target array. Using the sim_wwn command, you can also see that we can look at it from a WWN perspective, so this is helpful if identifying WWNs. And using the native command, you can see here that highlighting the device number along with the serial number that it currently has. So let's create a storage group called kt_tagging and just show you how to tag devices and how helpful this can be. The INQ command. So it's simply highlight the devices involved in the storage group, set volume identifiers, and just give it something useful like an application name, etc. And this application label will be put on all devices involved in this or highlighted in this example. So this was pre-migration, and we've cut out a lot of the migration, so we just do post-migration. So this is on the target array, and we can see that the finance app 1 that we gave it has followed the migration, so attached new devices. And this is the case through using the INQ command. We can use an identifier parameter, and it'll show the identifier finance app 1 along with the native array ID and label. Leaving out the native, you can see it shows 085 and shows identifier name. So these are helpful tools that you might use when identifying devices post-migration. So that concludes the video today. Thank you again for listening. If you have any queries on what you've seen or any other queries on NDM, feel free to contact me at richard.murphy@dell.com. Have a nice day.